Good. So today we will look at structures. Um, so let's say, how to work. If you are working with real numbers, you either use float or double, right? Uh, so float or double is a primitive data type. Float or double, it's a primitive data type. What is a primitive data type? A primitive data type is something which is given by the programming language itself. So addition on floating point numbers or double numbers, you don't need to do anything. You just use the addition operator and it automatically works for you. So, but now let's say, like in many math, uh, when you're working with mathematical problems, you have to deal with complex numbers also. So how do you deal with complex numbers? How do you differ? So what data structures you can use to deal with complex numbers? So one way of doing it is, like for example, you want to represent two complex numbers. So you can use something like this: int r1 c1, int r2 c2. So this r1 c1 and r2 c2, r1 c1 represents the real part of a number, and C1 represents the complex part of a number. Similarly, R2 represents the real part of a number, and C2 represents the complex part of yet another number, imaginary part of yet another number. And then you have, you say you have main. Let's use this. And then so you can read these complex numbers, and so you can read two complex numbers. All right. So you can use this, you can read complex numbers from the screen. So you can say kind of printf. Let me enter complex number 1. And so this is here, if you can see, scanf %d %. Let me, yeah. I'm using R1 and C1 as global variables, just like that, for no good reason. So here in the program, so we are modeling a complex number in a particular fashion. So we are modeling a complex number in a particular fashion. And let's say if you want to find the sum of these two complex numbers, we can kind of say printf sum of %d plus %di and %d plus %di is %d plus %di r1 c1 r2 c2 r1 plus r2. Are you with me on this code? C1 plus C2. How do I use multi-line things? I have to put backslash. Maybe if I have to do it, it's better to do it this way. Are you happy with this code? Does this code make sense for you? And one more thing I would like to tell, I didn't get time to show you how to do everything within VS Code. I didn't, when we started, I don't wanted to use VS Code to compile, run programs for a reason, because so I know like students who use Turbo C and other environments, they think programs run magically. And so if you ask the question like, how do you compile and run the program, they will say F9 or something like that. Okay, so that would be the dumbest answer you can give. So you can, but you should know, like you have to compile the code, you have to execute the code, and so because of that, I made it a point to see that you write code in VS Code and you use the command line to compile and execute. So that's the reason we did it. But now you know the whole thing. You no longer need to go through this thing. You can do the compilation, execution, everything within the VS Code environment. You need to set up few things. It's not too hard. Read something online. It is you can set up things. You can do GDB on the. I want you to know how to use GDB from the terminal, just not dependent on the VS Code to do GDB. So all these things, with the bare bones things, I would like you to see. So because of that, I didn't take that path. So GCC complex. Let me use 10, 20, 20, 10. Yeah. So it gives sum of 10 plus 20i plus 20 plus 30i. 10i is this. So yeah, so there is nothing fancy about this program, except this. The problem is in this program, the thing that the first imaginary number, complex number, is held by the two variables R1 and C1, and they are loosely coupled. They are coupled in your mind, but they are not coupled in the code directly, and so that's not a nice way to do it. So what do we do? So we kind of want to declare or write them in the form of use what are called as structures, where so we can say something like struct complex. Let's say struct complex. It is struct complex is a new type that we are defining, and then we have two numbers. So one is yeah. So int real. Sorry. Int imaginary, and complex here, let's say what should I use? There are let me use C1 C2 to indicate two complex numbers. So now, so if you want to, so now we have C1 and C2 are two variables. These are of type structures. And the type of the structure is, these are of the type struct complex. And so yeah, so what we can do, like for example, is if you want to struct complex sum is yet another complex variable. Sum is a variable whose type is struct complex. And how do we do addition? The way we do addition is sum dot real is equal to C1 dot real plus C2 dot real, and sum dot complex is equal to C1 dot imaginary plus C2 dot imaginary. And then how do we read these two numbers? So C1 dot address of C1 dot real address of C1 dot imaginary, C2 dot you can see this is nicely suggesting the some dot imaginary here. So all right, so this is how we can do. So are you all with me here? How things are progressing in this? So C1 dot real, C1 dot imaginary, and there are no specific there are no separate format specifiers for struct variables. C1 dot real is just like any other integer. So C1 dot real is like any other integer, and C2 dot imaginary is also like any other integer. So sum dot real, sum dot imaginary. Are you all with me on this code? How this is working? The important type here, the most important observation for you to make here is we have defined a new type, struct complex. Struct complex. This is a new data type. Let's compile this code. So C1 and C2 are variables of type struct complex, not complex. Complex is not the data type. Struct complex is the data type. So 10, 20, 20, 10, same. There is a question, can we use C1 plus C2? You cannot use C1 plus C2. No, Jatin, you cannot use C1 plus C2 because so yeah, we are creating our own data type. So this is the first instance of in this course. No, actually, yeah, maybe that's where we are creating our own data type. It's true. Struct complex is our own data type. What does dot imaginary means? Dot imaginary, does the compiler see a difference between two structs? What do you mean by that? Yeah, it will see a difference between two. Imaginary is just a, no, this 10, it's just a variable name. It's just a variable name in the structure complex, that's all. Similarly, real, it can be anything. This name can be anything. There is no, we can do C1 is equal to C2. That is, C1 dot imaginary, it is the member of the structure C1. C1 dot imaginary, yeah, the size of the struct complex will give us 8. That's true. Size of struct we can do C1 is equal to C2. It perfectly works. Like for example, if you want to do it without writing code, let's say GCC minus G complex add gdb a dot out break main run and next enter complex number 1. So here if you do print C1, So yeah, GDB is kind of clever. So it is automatically printing the different members nicely for us. But let's say if I do C2 is equal to C1, set C2 is equal to C1 and print C2. Does it make sense? You're not able to see the bottom of the screen. Is it a problem for everyone or? Zoom panel covers it, huh? Okay, I think you should be able to. This is what we did here. So just focus on this. Are you all with me on this, what I have highlighted? So we said the C2, set C2 is equal to C1. C1 is the first structure. This is in response to Kishore's questions. Can we do C2 is equal to C1? We cannot do C1 plus C2. That our addition operation is not defined. How will the compiler magically know that that's what? But C1 is equal to C2 should be fine because it's just the operation is well defined. You just copy the from one structure to another structure. Field wise. There is no operator equal to is maybe overloaded, but no addition. Addition is not allowed. Okay, I think we should proceed. Okay. We cannot overload operators in C. C1 is equal to C2. So one thing I want you to guys to understand as you know, looking at the questions that you ask, is you need to develop that thinking process. I'm mentioning all these things because we have a couple of classes left. That is why C1 plus C2 is difficult to is not supported, but C1 is equal to C2 is supported. It looks like Vivek is the question. That's the question I want you to think. So why some operators are supported, why something is supported, and what are the issues? So you need to develop that uh, thought process. So that comes with experience, and so that's what I would like you to develop. Anyway, so this is what it is, and let's now try to do a new. So now I would like you to. So we'll slightly modify this program, and so this is what we would like to do. So sometimes we don't want even want to do this struct complex, all this business. So instead we would like to use what is called as a so we will have this thing struct pay attention now. So we are using what is called as a type def. So we say type def struct complex is complex. So now we are defining a new complex data type. We are defining this new complex data type from this struct complex is complex. This is what we are doing here. So now what we can do is we can just say complex sum, complex C1, C2 sum. Are you with me here? This new type def stuff definition on line 15, we are defining a new type called as complex. No, this is a good thing. So this is the whole thing. This is the right thing to do. The struct complex, we are defining this whole thing with a new type complex where the C here is a capital C. It's not like an alias. It's a, yeah, you can think of it as an alias, but not, uh, alias kind of refers to memories, but this is not like that. This is a user defined data type. That's true, exactly. So struct complex is also user defined data type. And no, this capital complex is also a user defined data type. On line 19, you can see you have a nice definition, complex C1, C2, sum. Is type def also text substitution? I cannot say it is text substitution. Not sure how compiler internally implements it. Are you with me here on line 15? The new type def. Take one thing at a time. Just follow my thought process, wherever I'm leading you to. If you have questions, hold them for a while. Are you with me on line 14? How we have defined a new user defined data type called as complex. Good. So now let's say we want to modify this program and we want to do this complex star read complex. So we want to now define a new function called as complex star read complex. What it will do is when we call it, it reads a complex number and returns it. No, it's like a read complex. What it will do is enter a complex number, scanf. So here what it will do is complex star C is equal to malloc size of complex. So this is like I'm setting things up for the linker list stuff that we will be doing in the evening. So complex star C is equal to, so here on line 18, we are yeah. If you want to access a array, C is a pointer to a structure, and if you want to access the members of the structure, you will use C right arrow followed by real. But the only problem here is for scanf we need the address, not the value. So we put a address around the whole thing. And then what we do is we return C. So when C is not the particular way in which I want you to understand. So let's say we have something like this. Complex is C1 and complex star. Yeah, let me do one thing. Use CPTR. So if you want to access the members here for this, you use C.real. This is the syntax. C.imaginary. But if it is this, then we use CPTR, right arrow, real, and CPTR, right arrow, imaginary. What Pramod suggested also works, but you have to take address again for yeah. So you can do that also. What Pramod suggested, another way of doing this is star CPTR dot real. This will also work. I think so. Yeah. No, here I'm just giving an example. CPTR is declared here. Let's compile this program. Yeah, let's before we do. So, and it returns C. Let's, so here what we do is, so complex C1. So what we do is C1 is equal to read complex. So on line 28 and 29, we are reading two complex numbers. Okay. And then, so now remember C1 and C2 are pointers. Let's see if this is all making sense. Malloc is there anything? Oh, okay. Okay, so are you with me here? Can you all see what is going on here? What all the new things that we have seen? On line 10, we have this new type called a struct complex, but we want to use a much shorter and nicer form. So we have defined a new user-defined data type on line 15. Uh, So, and then, so we have written a new function called as read complex, in which it creates a complex number. It creates memory for a complex structure from the heap, and then it reads and sets the corresponding variables. Are you with me on the read complex function? Are you with me on the read complex function? Great. And then, so on line 29, so we have no read complex, no C1, C2, and we just add the two complex numbers. And what I would like you to do is pay attention here. Like for example, C1 and C2 are pointers to complex numbers. So we use the right arrow, but sum is not a pointer. Sum is a complex variable by itself. So we use the dot operator. Are you good? So shall I move on to the next idea? So the next idea is about what are called as unions. And so, yeah, let's see how we can do. So let's say you have hash include, yeah, st. So similar to the way we did structures, so there is what is called as a union also. Let's say, so we have a union object. Yeah, so let's say int x, int y, and so let's call it as the variable capital A for the sake of simplicity. So yeah, so here we have defined a what is called as a union. Uh, have what is called as a union, and so here the interesting thing is this. Let's say a dot x is equal to 10. Union dot c. So here what happens is the particular way in the case of structure, the memory allocated, if you see the memory allocated for the structure, so in the memory you will have two integers. One is for real, that's this is for this variable, and another is for this variable. But whereas in the case of a union, what happens is the memory that is allocated is the max of these two things. So here only one int will be allocated and both x and y will point to the same. This is kind of a bit tricky. You will understand why it is useful uh, in a moment. But let's see what happens because of this. So if I do a printf %d a dot y is equal to %d, then a dot y, and if you compile this, you can see we have assigned it the value 10 to a dot x, but a dot y also got changed because both of them are sharing the same common memory, right? So GCC, so let's do this using -g union. So gdb a dot out. So if I do print a, right now both of them they are yeah. So there is a good question. What if we had a car? Okay, so we will see. So if I print a, so it is x is equal to 0 and y is equal to 0. But if I say set a dot x is equal to 10 and cannot access memory at address. What happened? I should be able to do it. Oh, I didn't put okay, break name one. Okay, great. So now print a and set a dot x is equal to 10, and then if I do print a now, you can see both x and y are set to 10. Are you with me? Similarly, if I say set a dot y is equal to 20, and then if I say print a, then you will see both x and y are changed because both of them are pointing to the same memory location. So now let's see one more thing. There is this question: what happens if if this is so one interesting way of looking at to read how the byte representation of X is, I can say byte B of 4. So byte, so is byte a, is byte a user defined, yeah, let's use, I thought byte is defined in some, okay, let me use char, no problem. So, so now let's see what happens. Now there is no a dot x. So let's say 0x, f1, f2, f3, f4. This is a hexadecimal representation for this. And control D, yes, GCC union.c. GDB a dot out, break main, run. Huh. I think I didn't compile it using the. Okay, GDB a dot out, break main, run. So before the assignment statement, if I print X, this is what we have. So yeah, so what happens is now let next. What happened? Okay, run it again. Print I think maybe I'll have some dummy statement here. I hope you are able to see the experiment that I am. So Pratyaksh has this good question. So why it showed as 3 null? I think it's a particular way in which GDB is doing something. 364, 363, 362, 361. Yeah. I don't know what this incomplete sequence is, but in any case, the point I want to make is print p slash x a dot b of 0. Are you with me? Can you see what is the, so the byte, the least significant byte is f4, and that is getting printed. Are you all with me here? Print it in hexa format because we are doing the assignment. So what happens is when we do a dot x is equal to this, you are not taught about the representation of numbers in hexadecimal format. So f1 will go here, f2 will go here, f3 will go here, and f4 will go here. What is f1? F1 is 4 ones followed by 001. And similarly, f2 is 4 ones, f stands for 4 ones, followed by 0010, so on and so forth. No, it is this only. See, what I'm telling is in the memory location associated with the variable x, which is 4 bytes, this value f1, f2, f3, f4 is assigned. Okay. What is f1? F1, the binary representation of f1, f1 is in hexadecimal form, is 4 ones followed by 001. Are you with me on this one? How many of you understood this? At a high level, if you abstract away some details, because we didn't discuss about hexadecimal numbers in detail. So since both of these things, so this is this, but there's interesting thing is the same memory, it is called as, this one is called B of 0, and this is called as B of 1, and this is called as B of 2, because of the union, this is called as B of 3. So now if I do B of 1, so you see it is 0xf. No, everything hexadecimal value, it's converted into binary or stored as a binary in an integer variable, Vikram. Finally, everything is stored as zeros and ones only. It's just that how we are giving it, to the compiler to store is what is the difference. Are you all with me? How many of you understood this particular example? This is a small and sweet example which very nicely illustrates how union works. Because x and see the what is the base address of, let's say, in memory, in order to make this make it clear to you, in memory, the memory, there are 4 bytes will be allocated here. This is first byte, second byte, third byte, fourth byte, 4 bytes. So the base address, let's say the base address, the address of this byte is 100. The address of this byte is 101. The address of this byte is 102. The address of this byte is 103. So if you take the address of ampersand a of x, this is nothing but 100. This is nothing but 100. But the interesting thing is the same memory is also allocated to this character array of 4 bytes. So this is B of 0. So this is B of 1. So this is B of 2. This is B of 3. So when we access this memory as A of x, you get an integer. But when you access the same memory using B of 0, B of 2, B of 3, the corresponding characters will be obtained. B of 0 got F4 because this is what is called as a little endian convention. This is the least significant byte. The least significant byte goes to the lowest address. Yeah, this is little endian convention. If it is big endian convention, when you print it, you get F1, F2, F3, F4. And of course, one interesting thing is, in a, let's say in a down the lane in an interview, if they ask you write a program to check the endianness of a processor, then this is the code you should be writing. You just check B of 0. If B of 0 is F4, then it is little endian convention. If B of 0 is F1, then it is big endian convention. That's true. Character, no, 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 no. You don't get the same if carry of 4 is equal to 0x F1, F2, F3, F4. No, F4 is the least significant. This is the least significant byte. That's not. So little endian convention. So this is what is called as a little endian convention. Yeah, little endian and big endian convention. So in the little endian convention, least significant byte goes to the lowest address. LSB to lowest address. I'm running out of time. Actually, this is little endian convention because I want to cover one more thing on function pointers, but let's see. And if LSB, if MSB goes to the lowest address, Indian or Indian. So yeah, so I don't know, guys. Maybe it is Indian. Okay. So shall we move on? You think all this is why we are unnecessarily making our life difficult? So I want to give a real example where this makes sense. Shall I clear the screen and move forward? I hope you're all with me. I'm thinking there are many cool ideas, but we don't have time to discuss them. It's okay. Union 2.c. Yeah. So here, so let's say you are working with a objects. Okay. So you are reading objects. Some objects are no. Some objects are like a struct. Like for example, int length. If the object is a square, then all you need to know is uh, its length. But if the object is a rectangle, then you need to know its length and breadth. Right? So let's make it, and if the object is a triangle, so maybe you need to know its int side S1, or maybe you just want to know no, the base and yeah, let's say int side S2. There are three sides of the triangle you want to know. So depending upon which object we are representing, uh, so depending upon which object that we are which object that we are representing, we have to use some kind of flag. This flag will tell us whether it is a triangle or a square or a rectangle. Are you all with me on this example? And I would like to do a type def on this, type def whole thing into an object. And now I will say object S. So what happens is now is, what is the memory that is allocated to this, what is the memory that is allocated to this union for the variable S? What is the memory that is allocated to the variable S? This is a real example. So the memory that is allocated to this variable is, so there are, oh, actually this is more complex than this. Okay, let me do one thing. Struct object within this. Okay, guys, we are in real fun now. Yeah, I think we are good. Does it make sense, or are we making? Yeah, yeah. I think I should use that formatting thing. Uh, okay, awesome. Are you all with me here? What is happening here? What is the memory allocated, and what is the logic behind the allocating data structure for this? We don't need, huh? we need the name for the union. Union all this. Uh, let me call it as X, whatever that X means. What is the, so what, how many of you are with me on the logic? Why we are doing it this way before I ask the next question? Does this whole thing make sense? How many of you understand? So here what is happening is, this is a very interesting example. We want to store three kinds of objects. So one object is a square. If we want to store a square, all we need to know is we need to know its length. If you want to store a rectangle, then you need to know its, its length and breadth. And if you want to know store a triangle, you need to know its three sides. And I think maybe we need to use something to R for rectangle and T for triangle. Do you understand the big picture? So I want you to understand that there are three cases that we want to do. I have only 3 minutes to finish this. Number one is square, number two is rectangle, number three is triangle. And so depending upon this flag will store whether we are storing a rectangle, square or a triangle. So what do we do? So here now comes what is called as a enum data type, type def enumerate enum square, rectangle and triangle shape. So we will have what is called as a shape of the flag is this. The flag type is clear all. So now what we do is, so here on line 28, for example, let's say if you want to deal with a square, we will say s dot flag. I should use the word shape actually to indicate that we are working with a square. And let me use this and then if it is a square, then what is it? So how do we access this? So s dot we want to it is present in the union. So s dot x dot length is equal to 10. This is how we deal with a square. Does it make sense? How many of you are with me on this one? How we handled square? Enum is a new data type. This is like the shape variable can take square or rectangle or triangle, and square by default is no, what it does is it allocates, it says square is assigned 0, rectangle is equal to 1 and triangle is equal to 2. But we don't use those 0, 1, 2, but instead we use the square, rectangle and triangle, which are easy to understand. Shape is of the data type, this particular data type, this new data type, enumerated data type that we have defined. This is 1 byte. That this enum, this shape, no, this is only 1 byte because there are only 3 variables and no 3 types. Square 0, rectangle 1. The encoding for square is 0, rectangle is 1, triangle is equal to 2, and okay, so I think we should take a break here. I will push this code. What I would like you to do is, I would like you to take a look at this code and yeah, I would like you to take a look at this code. And in the evening 6 o'clock we will regroup. In the evening 6 we are going to look at two ideas. One is function pointers. It's a very, very important idea, and we will do one very fun thing with function pointers. That's number one. Number two is what do we do? Number two is linked list. These are the two things we will do. So we have a quiz tomorrow. So I think I will record the lecture. If you can watch the, like, whoever can attend. See, this is what, see, I don't want this course to overflow a lot to the next